So, till now we have seen the features of EIGRP, the configuration, the basic configuration of EIGRP. And this is where we stopped in the previous class. Now, what we learned here is the last topic. What we learned here is when you configure EIGRP, you have an option to use wildcard mask. As a result, you don't need to put any filter to stop EIGRP distributing routes. Say, for example, if I will run a RIP protocol on this router, and this is subnetted to the prefix length is 24. The prefix length is 24. And you see all starting with 172.16, which is by default class B. Even if you run a class full version of RIP, when you say I want to run 172.16.5.2 only under RIP, if you want to run only 5.2 under RIP, that will not be possible. It will take it as 172.16.0.0, which means it will run on this, this, and this. And later, to avoid RIP advertising routes in this way, in this direction, for example, you do not want to advertise on this direction. To avoid that, what we do is we say passive interface, serial 0. That is how the passive interface command used. So no advertisement of RIP will go this way. Whereas in EIGRP, you have an option of writing wildcard mask to say how many bits must match in order to run EIGRP on the interface which has got this address. So this is matching, only these two will be running EIGRP. There is no EIGRP here because there is no match in the third octet with number 5. That is what the user wants. User do not want to advertise the internal networks to internet people. The internal network should be local. If any network need to be advertised, we will use BGP or any static route in between autonomous systems. So it's not usual to see an IGP protocol between autonomous systems. Now, this is where we stopped. We are going further. See? When we have a network like this, I'm going to explain this page with this diagram. This is more nice. We have an ISP, say for example, this is the ISP router. And this ISP is in a network 172.31.0.0/24. Understand? It's not /16, it's /24. Who is an ISP? Who is an internet service provider? ISP is a network which is responsible for providing you the path information for those destinations that are not known to us, isn't it? ISP is a network who is responsible for providing us the path to reach unknown destinations in the public. So what we do is we go to this router, the edge router. Inside you got a lot of routers like A, B, C, D. You have many routers. We go to this edge router and say, hey, this is the network of ISP. This is the network of ISP, meaning this is the default network. Default means what? That's the only hop. So we say IP default network 172.31.0.0 to tell router A that if you do not know the path for any destination, just push the packet to this network. Means this is the network of ISP. Push the packet to the network 172.31.0.0. Now we also write in 172.31 to which address need to be sent. This address. This is the exact address of this ISP router here. 172.31.1.1. So we have said two things statically. Number one, which one is a default network? And in that default network, where exactly the packet needs to be delivered. So if anyone tries to ping 8.8.8.8 from here, the packet goes to A. Sorry, the packet needs to go to A, and A will deliver to this router. So the packet needs to go to A. Now coming to the original story, router B also should know the default route. Usually we used to write static default route saying any network, any subnet mask, when you do not know, forward it to A. But for how many routers you will write? If you want to write statically the default route on every router, if you have 100 router, you need to go to every single router and write a default route 0.0. Instead of doing that, we make EIGRP to advertise the default route to every inside. How? The same edge router where we defined the default route, the default network, we advertise it under EIGRP also. The default network, we advertise it under EIGRP. So this router A, what it does is, because it is a default network, while advertising also it clearly says what I'm giving is not a normal network, it is a default network. Star. D star. D means dual algorithm, means EIGRP given route. It's not just simple route, it is a default network. So if B wants to reach 8.8.8.8, which is Google's DNS, even though the routing table of B do not have 8.8.8.8 route, it will forward it to this network. This network it needs to reach via this 10.64.0.2, which is the very next router. And when it comes to very next router knows where to forward, and it delivers. In short, what I want to say is, instead of we writing default route on every single router, we make use of EIGRP to distribute the default route. So one advantage is your work is getting reduced. Secondly, if anything goes wrong on this link, if anything goes wrong in this link, this default network will fail. This default network will lose its weightage. As a result, EIGRP will not advertise this. As a result, routing table B will also remove this, which is dynamically getting converged. If you don't have EIGRP to distribute this default route, you might have written a static default route, and when the connection to ISP goes down, you need to go to every router to remove the default route now. In a small network, it may be easy, one or two routers, but in a large network, very difficult. So EIGRP allows us to distribute a default route which reduces our manual configuration of default route. Not only that, when there is no chance of reaching ISP, it removes the default route by sending an instant update, which is also providing a fast recalculation of paths or fast convergence. Do you have any question? I'm going to do this lab and demonstrate to you. Do you have any question before that?
No, sir.
All right.
No, sir.
Okay. By default, it is class beam, but I have extended the network portion to /24. And on this ISP router, I said R1 is like an ISP for us. We got 190.10.0.1/24. On this side, I'm going to give .2. So the ISP part is over. Now let's get into the inside. Inside I would like to have 172.16.36 or 32.3. 43. Right, and then for testing we need some loopback interface. Let's say 4.4.4/32 and the loopback interface 3.3.3.3/32. 2.2.2/32. And some networks are going to be behind R1, like Google's address. Just two I'm keeping. There may be 1 million network behind R1. Secondly, I do not want to do natting now. So if router 1 needs to respond back, router 1 needs to know the inside 172. So I'm going to write a static route on ISP. See, this is just to simulate. ISP will not have any static route towards provider. But in our case, for the return traffic, if you ping from R4 to 8.8.8.8, R1 should respond back. For that, R1 should know the route. For that, I'm writing a static route. In real world, we used to do natting. I don't want to make this. This is already a little bit complicated for you, the default network in EIGRP. I do not want to add more complexity to this. So let me have a simple solution. I'll have default route from R1 towards ISP. Sorry, towards service, towards the customer. IP route, or you can also write the customers in 172.16 or whatever the subnet whatever the prefix length is, send it to 190.10. Now if I say that, then you cannot ping with 4444. So better I'll say any network. Just send it to 190.10.0.2. This is for the return traffic. Okay, now let me start the configuration. R8, R1 has got 8.8.8.8 on the loopback. Done. Show IP interface brief. We got an address on the physical interface 190.10.0.1, and we got two addresses on two loopback. So the routing table also should show this. Show IP route. We got it. And this is the static default route that I wrote for the return traffic. Static default route. Okay, now let's move on to router 2. Interface G3/0 190.10.0.2 setup. And as we already planned, we are going to advertise, or we are going to define IP default network command 190.10.0.0 as the default network. And we're also going to say that, hey, IP route in this 190.10.0.0 you need to speak to 190.10.0.1, which is the exact IP address of ISP. That's it. Now, these are not related to EIGRP. This is how we can use a network as a default. Next, let us finish EIGRP from R4, and then we'll come back to R1. R4. I'm going to use a notepad to make it fast. Router, EIGRP. Let's say the autonomous system number that we want is 111. Network 172.16.0.0. Network 4.0.0.0. No auto summary. This goes on router 4. Yeah, do you have any question?
Sir, when you say no auto summary, what does it do? You explained in the previous class, RIP, but I forgot.
See, by default, the EIGRP protocol and RIP protocol summarizes. So when you have 172.16.43/24, it will summarize to class full 170.16.00 to /16. You understand?
Okay,
So
sir.
by default,
Okay, sir.
it will advertise the summary only. We are saying no, don't summarize. That is what we mean, no auto summary. Do not summarize.
Okay.
But good news is the newer version of EIGRP will not summarize. I'm running a newer version of EIGRP, but still I'm saying no to summary because you should know that there is also a version of EIGRP which will not cancel this auto summary. We have to cancel by saying manually no auto summary. But today, most of us have migrated to newer version, so there is no need for this command. But all those who have got the older version like 12.4, which is very popular, and the previous versions 12.4 and up before, all you need to type this command no auto summary. Now you see on R3, I'm not going to say no auto summary, and you will see it is not summarizing by default because it's a newer version. Now on R3 we have F00 with 43003 here, and this is going to be 3, and I got another interface F01, and this is going to be 33 here. So this 170 is more than enough to run EIGRP on both F00 and F01. I'm removing this no auto summary to prove that the newer version doesn't need this. R3, let me paste it. You're going to see a neighbor, EIGRP neighbor, you see. It has formed a neighbor, EIGRP IPv4 version 1111 is the autonomous system number. The neighbor is 172.16.43.4, which is router 4 or the router on the left. A new adjacency is formed, and the dual algorithm is behind EIGRP doing this. Now, I want to show you that show IP protocol. Here we see auto summarization is disabled because it's a newer version. In the older version, it was enabled always. So we used to say no auto summary. In R4, show IP protocol, even here you see disabled. It is not because I said no auto summary. It is because by default it is. This is how it is. Fine. Then to enable what you need to do, put auto summary. Put the command auto summary. Because by default it is no auto summary. And what else we see here? We see that we are running EIGRP 11111. So when it learns route from 11111, it gives to another neighbor who is also in same 11111. It's what it called as a redistribution. It forwards the route to only those neighbors which is in same autonomous system. And these are the 5 K values in which only K1 and K3 are considered. Bandwidth and delay are considered. Rest all are multiplied by 0. Anything multiplied by 0 is 0. MT multiplied by 0 is 0. Reliability multiplied by 0 is 0. Load multiplied by 0 is 0. Delay multiplied by delay is, delay multiplied by 1 is delay. Bandwidth multiplied by 1 is bandwidth, meaning you consider those bandwidth and delay values. All the rest you do not want to consider, so you cancel by saying 0. Okay, so next is here. Administrative distance for EIGRP is 90. If you will learn any route from external, meaning like OSPF, into EIGRP, the administrative distance is 170 for those networks which was originally generated from OSPF domain, which is coming to EIGRP through redistribution. So those external routes, administrative distance is 170. And if you have multiple paths with same metric, 4 path or of many, only 4 will be considered. Even though the metric of EIGRP is not hop count, but still there is a limitation in hop count. The EIGRP protocol can support only 100 hops. Cisco has made this as default because more the network, more process utilization. EIGRP cannot handle more networks, more routers, more networks. So EIGRP cannot handle that much. So the Cisco has reduced the number of hops to 100. But if you want to increase this, you have a command called max hop command. So for example, I will go here and say router EIGRP 111 max hop, maximum path. No. This maximum path is to increase the path for load sharing. So let me say the default is 4, I'm saying 8. What's the maximum? You can say up to 32. I made it as 8. Now I want to increase the hop. also hop command, max hop command. Okay, that will be under. This is a newer version, so that will be under topology. Mhm. Mm. Let me check under EIGRP. If it is not there, then I'll check with default. Just go only maximum path. In older versions, we had one command called max hop. Okay, so there we can increase up to 255, but I think the new version don't support up to 255. You can have only 100. 100 is actually uh, more than enough.
So, a question in a small organization, how many routers do you
Mm-hmm.
usually have?
Uh, see, small or big, that doesn't determine how many routers. It is all what sort of work the enterprises do, how many employees they have, and how many departments they have, how big the organization. Meaning, I have seen a very big organization having just 6 devices. I tell you, if that organization is down, the entire country will not get internet. Such an ISPs of ISP, it is not simple ISP, it's an ISPs of ISP. Though they are considered to be very big, because if that is shut down, the entire country's internet is shut down. They are the one who bringing the internet inside this country via fibers under the ocean connecting to other continents. But the number of device 6, 4 main device, 2 switches, something like that. So, if you take a simple company with 1,000 employees, you may be having like 20 device, 25 device. Again, we don't know how many departments they have because, routers need, if you want router, sorry, for multiple networks, you need routers. If you don't have too many networks, then you don't need a router, you need only switches. So again, we cannot predict, but I'm telling you, this 100 itself is a very big number. More than enough. See, I changed the max path to 8. It is changed now. Even this was allowed to change up to 255 in the older version, but not in this version. How can that be? Let me try one more time. EIGR router, EIGR 100. What max path? Maximum hop. Okay, so forget about that. What I'm saying is, the older version it was there. In the newer version, the maximum hop is 100. Again, that is more than enough. But what if I have 100 in one router? No answer. You need to change OSPF. You need to switch to OSPF. But in the older version, we had an answer. You can increase to 255. If you, I did not say no to summarize. I was telling you by default it will summarize show IV protocol. You see, the automatic network summarization is in effect, meaning it's right now effective. Summarization is happening, and we see the max hop is 100. Now, you see, I'm going to cancel the summarization first. Router EIGRP 10. No auto summary. Let's go and verify this. After I say, you can see not in effect. Next, we're going to increase the max hop command. Router EIGRP 10. Router EIGRP 10. Even in this, we don't have the command. But I've seen the older versions, they do support max hop. You can increase the max hop to 255. Even here, I don't see the command. Okay, we're going back to our genus 3. All right, the last router 2 don't have any EIGRP. I'm going to put EIGRP on router 2. Router 2, what is there right now is show IP interface brief. I have given the IP address which is facing the internet, but there is no IP address configured on F00. Neither the loopback interface. So let's go back to our notepad again. I'll remove this, and this I'll make it as 0, and this is going to be 2, and this is going to be 2. The EIGRP is running on F00. If I put this, it will run on F00 and 3. And also, I'm going to add network 190.10.0.0, which I have already defined as default network. You see, we have already defined it as default network. And that is what I'm going to advertise under EIGRP. So EIGRP will not advertise this as normal network. It will advertise with special marking saying this is a default network. I want to capture this and see how it looks. So I'll start capturing here to see what router 2 informs about the network. These are all hello packets going every 5 seconds from EIGRP. How do I know it is EIGRP? Because the multicast address 224.0.0.10 is EIGRP. I also see here in the protocol field it is EIGRP. Now I'm going to hit enter here on R2. Oh, I need to paste this configuration. All right, I do this. Now you'll see hello going from 172, 16, 33, 2. Yeah, it has gone already. Now I'm superhero of Wireshark, so I'm going to use some special command. What is the address of R2? 172.16.33T. 2. 172.16.33.2. I'm asking to show only those packet that went from router 2. So this is the very first packet. I think I have to stop now. This is the very first packet, 24th packet. See in the left. It was going from router 3. And the payload, the length, these are all normal. But this is something bulky. So I'm expecting update in this packet. See, it's an update packet. Other packets, if you see, they are. Oh, that's also an update. Hello, this is hello packet 86. This is also an update packet. This is also an update packet. This is also an update packet. All right, now this is what I was talking to you. So what router 2 is advertising is it is advertising about 3333 172.16.43 and 4.4.4.4. Anyway, those things are not necessary for us because those things are here. And this is coming from router 2. I'm not interested in this. These are all internal routers. Okay, so I'd like to see this one. Here it is. 192.10/24. 192.10/24 is the network, which is here in ISP we have defined as default, and we have also asked the EIGRP to advertise it as default. So router 2 is advertising this network, and the prefix length is /24. See the bandwidth and delay, which is considered. The MTU is not going to be considered. Hop count is not going to be considered. Reliability, no. Load, no. So there is no tag. I don't see anything interesting in this. All right. Let me check. That's all or hello. 74. Again, hello. Some hellos are only 74 size. All the rest are hellos actually. So this is only the 2 packet. These are the 2 packets which just got update. And I don't see any clue, but let us go and see whether the other router knows about a default. I'll go and check on R3's routing table now. I want to see a default network. show IP route EIGRP. No, that's what. It is still not learning the start default. So there is some mistake done on router 2. That's why I don't see it in capture or any difference. All right, let's begin the capture one more time and correct our mistake. There is some mistake done on R2 which we need to correct. All right, so I'll go to R2 again and see what mistake I have done. Show run section router EIGRP. I have advertised the network. Here there is no need for summarization. I'm going to make it as auto summary. Let me see whether this will make any difference. All right, now I have done some changes. I see some updates. I stop the capture. And then I'll go back to router 3 to verify. Router 3 is in the middle. Earlier I did not see any D start, but I do see it now. Cuckoo, cuckoo. So you need to know that there is no need for summarization here, so we need to say auto summary to achieve this. Okay, you got a default route. Now let's see the difference in the capture. Hello packets, hello packets. By seeing the size, I can easily know that it's not a hello. 137 is an okay, it's a query and reply packet. Look at this. It's saying 192.168.0.0 is not /24/16. You see, to poison this route, which route? /24 length route. It has put too much delay and very less bandwidth. Whereas on top, if you see, very less delay. That's how it removes the old route by poisoning it. Now, do we see any difference? Any marking saying it's a default? Don't know where it is. But there should be somewhere. Okay, there's a payload again here. No, I couldn't see inside the capture. See, this Wireshark will not show everything. It will show only the default things. Because Wireshark is also an application which is developed based on what is default. So anyway, you got a default route here. And let us check it in R4 also. Show IP route, show IP route. You do see a default route. And I don't have in the routing table route to reach 8888, but when I ping 8.8.8.8, I should ping. So I'm expecting ping because the default route is there. To go to this network, it needs to go to router 3. This is router 3's address. When it goes to router 3 will also use this default route. We'll also use this default route to forward the packet to router 2. And router 2 has got a static route, show IP route, static route saying 192.16 is the network responsible for all unknown net destinations, and this is the IP to which it needs to be delivered. First of all, let me check this reachability, maybe because of, okay, it is reachable. Let me try pinging from here 8.8.8.8. It is pinging, which means by the default route is working. Here it is working. So you see you got a default route, so it works. It works, and EIGRP also knows that this is default. But why it's not pinging from R3? Let me try pinging again. Ping 8.8.8.8. I want to check whether the packet comes to R1. I'll go to R1 and debug IP packet. I'll ping again here. Okay, this is the simple EIGRP packets. No, that's not the one we are looking for. We are looking for ICMP. The packet is not even going. Let me cancel the auto summarization here and check the router EIGRP 111. Do I have 88888 on R1? I do. Lubbock 0 has got 88888. What? This is pinging. Which means, yeah, this will ping. This is where the problem is. Router 3 is not using the default route. We got a default route, but it's not working. Actually, it should appear here. Gateway of losses resort is not set. No, it should be set to this network. Why is this version behaving like this? 777 is the ISP's network. We have 888 today. It was 777 the other day I was using. And when you ping from router 3, which is here, 20 network is the default network. You are able to ping. Okay, so it works. It will work in your operating system in your GNS3. Mine is somewhat unusual. We have even checked